Hey y'all, welcome back. Tonight's homework is all about finding limits from tables and graphs. So we're trying to find limits as x approaches a certain point rather than x approaching either infinity or negative infinity like we did in the last homework. And so really the key takeaway from the lecture should have been that in order for a limit to exist, both the left and the right hand limits have to agree. So what we do for the most part as we look through the tables and especially the graphs is just follow the value of the function on the left-hand side and the right-hand side of whatever c value we want x to approach. So part one says to complete the finding limits graphically assignment on delta math. You don't need to show any work. I'm not going to be looking for you to show any work, obviously, but I will be looking on my end on delta math just to make sure you complete those. So I just really want you to be practicing these so that finding these limits from the graph comes a lot easier to you. So let's just skip to part two here. It says use the graph given below to answer questions 1 and 2. Number 1 says, which of the following statements is true? So let's just run through these. 1 says the domain of this function, m of x, is all values between -8 and 5. So in order for this to be false, we just need to find one counterexample. In other words, one x value where the function's not defined between -8 and 5. And we see -8 is over here, and positive 5 is over here to the right. So if we can find at least one x value that has no graph or is not defined, then that's going to be false. And we can see very clearly that between 1 and 3, there's nothing going on here, right? And so the domain is not going to be between -8 and 5. It will be everything except, it'll be everything between -8 and 5, but not including the values between 1 and 3. So this one's definitely not going to be correct. The second item says that the range is all the values between -4 and 3, inclusive. So here we're looking at the y values. And so the minimum y value here is -4 down here. And then the maximum y value is 3. So what we're looking for to either like prove this right or wrong is to find, again, a counterexample. So is there any y value that does not have a corresponding x value in between those numbers? And as we look up, we could see, okay, so we've got some values here. This all looks good. It's defined, defined. There's really not going to be anything that's undefined here. So this is going to be true. So two works out. And the third item says that there are 3 values of x where m of x equals -1. So m of x equals -1 along this horizontal line here. Okay. And so are there 3 values where m of x equals -1? I see one right here. I see one right here. And I guess really the tricky part of this question is understanding, oh, this is jumping around on me, is understanding that this, okay, having some technical issues here. Bear with me. I'm going to just zoom out a little bit. Maybe that'll help. Is that this item right here, this point, since it's not colored in, is indicating that that is not going to be a point on the graph. So really what this is saying is that all these points here are going to be on the graph, and really everything up into that point, but not including that point. So really there's only going to be 2 values. So unfortunately, 3 is going to be wrong. What is the deal here? I'm jumping all over the place. Sorry about that, y'all. Try to keep this steady here. So the only correct answer here is going to be B. Number 2 says fill in the blanks, and this is going to be asking about specific limits. So the first one is the limit as x approaches 4. So as we calculate these limits, we want to be checking the behavior of the graph both to the left of 4 and to the right of 4. And if those two one-sided limits agree with each other, then we do have a limit. So x equals 4 is right. Okay, I don't know what's going on. Cammie is just like having a fit. X equals 4 is right here. And so as we approach the function from the left, let me erase that. Maybe we'll zoom in a little bit more on here. As we approach it from the left, we can see we are getting closer to 0. And as we approach it from the right, we are also getting closer to 0, right here. This little section of the graph is continuous, which is really, really good for limits to exist. And so we've got, the limit's going to just be 0. Letter B says what? Oh, so this one's asking x must approach what for the limit to be -1? So first of all, we want we want the value to be approaching -1 from both the left and the right. So we can see that happening. It looks like it's only happening in one place. So that's going to be happening. Here's where the value is -1, right? We're looking for the function value. And it's not going to happen here because there's no left-hand side here. Or I guess it's down here, right? Yeah, so this is not going to be approaching the same thing as this. All right, so it's not going to be -2. And then looking at the other place where maybe potentially we could have an answer would be over here at x equals -5. But we can see, again, the left and the right-hand limits as x approaches -5 don't agree. So it's not going to be this one either. The only time that's going to happen is going to be right here. Right, we can see that this section is approaching this section. We are going to have to kind of estimate this because we don't know exactly what that is. I'm just going to say it's 3.5, but that is an estimate. It's kind of hard to tell it. Erasing all the sketching I have on here, it does look like it's a little closer to 4 than 5. So if you put something like 3.7, I'm fine with that. I'm not going to be too picky about what number you put here. It's just got to be clearly between 3 and 4. And actually, I would prefer, since it is looking like it's a little bit closer to 4, that you write a number that's something between 3.5 and 4. 7's fine. I'm not. Again, this could be 6. It could be 8. I'm not really sure. It's not clearly labeled, but this is good enough. Letter C says m of what is -3. So we want to know m of what is -3. And it looks like we may have two answers to this because the value of the function is -3 here, also over here. So we're definitely going to have to do some estimating here. One of the answers could be 1. We're not talking limits here, so we don't need to be worrying about approaching it from either side. And then it looks like the other one is over here, in between -4 and -5. I'm going to call that -4.2. So I'm going to say also roughly -4.2. So I guess maybe a better way of saying that would be m of -4.2 is approximately -3. I think maybe for next year I might fix this graph so that we don't have to do so many estimates here. Letter D says the limit as x approaches -5. Okay, so if we look at where x is approaching -5, we kind of already talked about this earlier when we were trying to figure out when the limit was -1. If we look at where x is -5, right here, and we approach -5 from the left, we get a limit approaching 1. If we approach -5 from the right, looks like the value of the function is approaching -1. So up here, we get the limit as the x approaches. Well, that's kind of ugly. Let's try that again. The limit as x approaches -5 from the left of f of x, or not f of x, but m of x, is going to be 1. Over down here, the limit as x approaches -5 from the right of this function m of x, that would be -1. And we do have those one-sided limits, but whenever the one-sided limits do not agree, we say that there is no limit there, and so we're going to say DNE, or does not exist. Letter E is asking about the limit of this function as x approaches -2, and then you see there's a little plus sign in the top right there. Just a reminder, that little plus sign here means only the right-hand side is what we're going to be looking at. This is, we're only considering what is known as a one-sided limit, and in this case, we're going to be approaching -2 from the right. So looking at where x is -2. God dang, come on. Okay, it's right here. And so we're approaching x equals -2 from the right, and it looks like we're pointing at the y value -1. If this were asking if it was the limit as x approaches -2 from the left, then we would be approaching -2 on this little curve here, and we'd be approaching -4. So this is just, a little heads up that this would be true, although this is not really what the question is asking for. But I guess I should have read a little bit further, because F is asking for when that happens. So we have our answer here. It's going to be -2, but only from the left. I guess I don't need to write this twice. Okay, very good. So that's the first section. Hopefully we don't get so much jumping around on this next section. It says, given the following table of values, predict the following. So the one thing about this is the wording on this question is pretty intentional, predict, because if all we have are these values and we have no other information about it, we can't really assume exactly what's happening. But I think what we're going to do is, just make a fair assumption based on the numbers we see. So we can see that here's our x, as x gets closer to 2 from the left, the value of the function, it looks like is getting, you have 2.67, 2.76, 2.91, 2.98, looks like it's getting closer to 3, right? As we approach 2 from the right, so this is like our x from the right. So as x approaches 2 from the right, x approaches 2 from the left, it's over here. And we look at our y values, it looks like we're approaching 6.36, 6.23, 6.12, 6.03. I think it's safe to say that this appears to be approaching 6. Now, when x equals 2, we have a value that's 8, right? So this is going to have like, a behavior where the graph is going to come up. It's going to not be defined at x equals 2. It's going to be defined like at 8. And then on the right-hand side, it's going to be something like this. Okay, so it's kind of a weird-looking graph, but it's going to do something like that. I guess this will be going up, right? Nevertheless, that means the left and the right-hand limits are not going to agree. So part A is asking for the right-hand limit. So the limit as x approaches 2 from the right, and we can see that that's going to be 6, or at least it appears as though it should be 6. Letter B, as x approaches 2 from the left, the value of the function seems to be approaching 3. The limit as x approaches 2, like period, this is where it only exists if the left and the right-hand limits agree, which they do not. The right-hand limit's 6 and the left-hand limit's 3, so this limit does not exist. But even if the limit doesn't exist, we still can have a value for the function there. The value of the function when x is 2 is 8. And so that is the actual value of the function. Number 4a says, explain in your own words what is meant by this equation. I guess, really what this is saying, the way you would read this, first of all, is the limit of f of x, or instead of when, I think I'll say as x approaches 3 is 6. But what that really means is that both the left and the right-hand limit agree. It says in your own words, so I'd really prefer you not write exactly what I'm putting. You can kind of explain it in your own way, but basically what you want to say is that the left hand and the right hand limits agree. So something like the function's value approaches 6 on both the left and right hand sides of 3. is probably a better way of writing this. And, like I said, this is just some kind of freewheeling here. You could put this into your own words. I'd really prefer you put it in your own words. If all you do is just copy exactly my verbiage, I'm going to be able to tell that right away. I'm not saying you have to like completely change everything, but just make sure you're conveying the same kind of message, that the left and the right hand limits agree. So this is saying, is it possible for this statement to be true and yet f of 3 is 10? So in other words, like, is it possible that the function doesn't actually equal the limit? And of course, we talked a lot about this in class. This can be true. Yes, of course. Okay, and the way this would be true, or one way this could be true, there may be a removable discontinuity or a hole at x equals 3 with the point 3 comma 10 also being part of the function. So in other words, what this would look like on a graph is, you've got the graph approaching 6 here, right? Doing something like this, but there's a hole. So let's say, this is just kind of sketching it out here. So let's say this is 3, here's 6, but the function's actually defined somewhere up here. We still have this limit, but as x approaches 3, but the function can still be defined elsewhere. So yeah, this can definitely happen. In fact, this is going to happen a lot. Number 5 says, use the given graphs to answer the following. So these should be pretty rapid fire. We're just basically testing the left and right hand limits, making sure they're in agreement, unless they specifically ask us for one of the one-sided limits. So A says the limit as x approaches 2. So we're going to look at 2 and see, here we go again. So as we approach 2 from the left and we approach 2 from the right, we can see both sides are pointing in the same direction. Then that's 1, 2, 3, 4, 5. So it's going to equal 5. The next one says the limit as x approaches -2 from the right. So let me erase this. -2 from the right is going to be right here. So we can see as we approach it from the right, the value of the function is getting closer to 1. If we were approaching it from the left, let me just bounce down to D here real quick. That one-sided limit is going to be equal to -1. Not 1, -1. Since these two do not agree, it doesn't ask for this, but the limit as x approaches -2 would not exist. So just a little extra bonus piece of information there. Letter C says the limit as x approaches 1. So as x approaches 1 from the left and from the right, even though we have a removable discontinuity here, like it was asking about in the previous 4b, it's still, this limit exists, and it is 1. The limit as x approaches -1, well, the function's continuous at -1, so we really don't have any issues whatsoever here, and it's going to equal 4. And then finally, the limit as x approaches 4. Let's see, 1, 2, 3, 4. Again, the function's continuous here. We haven't really formalized the idea of continuity yet. I keep saying, oh, the function's continuous, but we haven't really talked about what that means. We will shortly, though. I wouldn't worry about it too much. So this limit's going to equal 0. Number 6 says sketch a graph and with an example of a function f that satisfies all the given conditions. So your graph will not necessarily look the same as mine, and that's okay. As long as these conditions are met, then you're going to be good to go. So I'm going to start actually with the points, because these are going to be well defined. These 2 points should look exactly like mine graph. So if f of 3 is 3, then we've got a point at 3, 3. So there's definitely a point here. And then there's also a point at -2, 1. So these 2 points are fixed, right? Those 2 should look exactly the same. As far as the limits go, this says that the limit as x approaches 3 from the right is 4. So that means whatever your graph is doing over here, it's got to be getting closer to 4. There has to be an open circle here because a function can't take on 2 values for any one x value. It doesn't have to be all wavy like this. It could just be a straight line. It could do something like this. then that's fine too. But the point is that it is approaching 4 from the right. It also says that the limit is approaching 3 from 3 from the left is going to equal 2. So same kind of idea here. We should have an open dot here, and some graph that's going to be pointing to that. Let's see here. I'm going to just go a little bit out because I want to make sure I can satisfy the last condition here, which is that the limit as x approaches -2 is 2. So the limit as x approaches -2 is 2 means that we should have agreement on our left and right-hand limits here. So I'm just going to do something like this. And your graph really shouldn't look exactly like mine. Hopefully it looks a little bit different. There's really not a ton of variation that you can do on this. What really has to be the same is, again, these 2 points have to be there. These open dots, whoa, where did that come from? Interesting. Nope. I don't want any of that. What is it? I'm always having trouble with this thing. I don't know. There we go. Somehow I got rid of it. Okay. Let's back it up a little bit before I got interrupted there. So what has to be here, these 2 points have to be here. You definitely need these open dots in there. Those are fixed. The rest of the graph can look kind of like whatever you want as long as, they're connected. So like these 2 points, actually, they don't even have to be connected. You just have to make sure that there's something coming off of this this open dot here, and then something coming off of this dot here. Otherwise, like you can have whatever you want happening in between. Same thing up here. There should be something coming off of here. Let's clean this up a little bit. Number 7 says, what are the equations of the horizontal asymptotes? This is just kind of a throwback question to our homework last time. And so to break this down, you got to make sure that we realize that when you take the square root of x squared, we do get plus or minus x. So algebraically, what happens here is if we factor out this square root of x squared separately, and I factor out the x, I guess I could just leave the x there on top because we don't have any other terms. I have the square root of 1 minus 1 over x squared. We can kind of see what's going to happen here. We're going to get 2x over plus or minus x times root 1 minus 1 over x squared. So as far as what the horizontal asymptotes are, as x goes to positive or negative infinity, this term right here is going to go to 0. We can also reduce the x's to 1. The square root of 1 is 1. And so we get plus or minus 2, right? It's going to be 2 over 1, but that's just going to be 2. So we are going to have 2 horizontal asymptotes. So our answer is going to be D. That about wraps it up for tonight's homework. Sorry for some of the technical difficulties, but hopefully you found this helpful. As always, if you have any questions, please don't hesitate and come ask me for help, and I will be happy to help you. That's it. Y'all have a great night.